Hey there guys, how's it going? Mike coming back at you here with another video on Calculus 1. In the previous video, we went through some optimization problems. Problems where we're taking what we learned earlier on in our course as far as finding the locations of local mins and local maxes of functions and being able to minimize or maximize a particular quantity given some certain constraints. In this video, we're going to begin to get into why continuity is such a big thing in the world of calculus, and we're going to look at some theorems that rely on continuity, the first one in particular, which we will get to very shortly. So as a little bit of background to this theorem that we're going to see, sometimes we want to know what is the minimum and maximum value of a given function over a particular interval that we're told. And while this is the main question that we want to answer, sometimes we have to ask ourselves the first question of, can we even find a minimum and maximum value for our function on our interval that we are given? Is it even possible? Because based on the interval and the function that you're given, this may not be something we could find. So the theorem that we're going to talk about, the extreme value theorem, or EVT for short, this theorem tells us when we can find a maximum and minimum value for our function over a particular interval. The theorem states, let f of x be continuous on the closed and bounded interval a comma b, then f of x attains a maximum and minimum value on the closed and bounded interval a comma b. Now there are some notes we have to make clear on both the hypotheses and the conclusion of this theorem. First of all, you may be wondering, what the heck does closed and bounded interval mean? Really, all it means is that it's an interval where both endpoints are real numbers, and the type of bracket that you have on both of your endpoints are square brackets. So both endpoints have to be real numbers, and the brackets on each of those endpoints have to be square brackets. If even one bracket on one endpoint is round, it's not closed and bounded. If either of your endpoints are negative or positive infinity, your interval is not closed and bounded. So these are some samples here. The first one, -2 comma 5. This is not closed and bounded because we have a round bracket on the -2. The other two, 4 comma infinity and 0 comma infinity, are not closed and bounded because we have infinity as one of our endpoints. And that's not a real number. It's not a finite quantity. The other part of the hypothesis of this theorem is that the function has to be continuous on the entire closed and bounded interval. So you have to check, does our given function have any points discontinuities, or any jump discontinuities, or any kind of vertical asymptotes, or any kind of thing like that on the interval that we're given. If we do have any one of those three things happening, then the function is not continuous on the closed and bounded interval, and our hypotheses are not satisfied. Now, the other thing that I want to be clear is that just the statement of this theorem, it does not tell you how to find the minimum and maximum values. It simply tells you if you can, or when you can find a maximum or minimum value. It only tells you when you have a smallest and largest value for your function. There is a method that you can use to come up with this smallest and largest value. We're going to see that in the next slides coming up. But just the statement of our theorem does not tell you how to find them. It just tells you that they are there when you have these particular things happening. So here's how you would go about any kind of problem where you have to use the EVT. You would be given a function f of x, you would be given some interval, and the question would say find the minimum and maximum values of f of x on the interval so-and-so. First thing you always want to do, you always have to do, check to make sure that the hypotheses of the theorem are satisfied. You have to make sure that A, you have a closed and bounded interval, and B, you have to check to make sure that the function is continuous on that entire closed and bounded interval. It has to be continuous for every x value in there. If there's even one x value where your function is not continuous, then your hypotheses are not satisfied. If your hypotheses are not satisfied, you would simply say we cannot use the EVT and state which hypothesis is violated. But for the most part, you'll see problems where your hypotheses are satisfied. So once you've checked that they are, here's how you continue on with your process. Next thing you're going to do is you're going to find the stationary points of your function f of x. So just as a quick recap, to find stationary points, you find f prime, you set it equal to 0, and you solve for x. Now, a side note out there, in the big wide world of EVT problems, you could have a rational function as your f of x. You would also include in your stationary points, you would also include any x values that make the bottom of your fraction, that would make the bottom of the fraction that would be f prime equal to 0. So you would include x values that make f prime of x undefined. But for my classes, for the most part, you're not going to see this. You'll just have to concern yourself with the values that make f prime equal to 0. But just note that that is one more possibility out there. Once you've identified all the stationary points, you're going to then find the ones that lie within the interval that you were given in the problem, and you're going to carry those with you into step 4. It's fairly often that you'll come up with some stationary values that do not lie within the interval that you're given in the problem. We don't care about any stationary values that are not in the interval that we are given. Once you've taken the stationary values that lie in your interval, you're going to take each of those guys, as well as the endpoints of the given interval, and you're going to substitute each of these guys into your function f of x. When you substitute each of these guys into your function f of x, you're going to come up with some number, and the largest value that you get out of all these numbers is going to be your maximum value, and the smallest value that you get out from plugging in each of these numbers is going to be your minimum value. So it's a 4-step process. Overall, not much new that's happening here. Everything that we're doing in this process, we've already done for something earlier on in this course. In the next video, we are going to take a look at how do we use this 4-step method, and we're going to do some sample problems with the EVT. So if you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy.